And this is lab number 9. Talk about asymptotes, horizontal and oblique asymptotes in particular for rational functions. When dealing with a rational function, you can think about your function as two separate polynomials. You have p of x, which is your polynomial on the top, and q of x, which is your denominator. It's a polynomial that's in the bottom. And when you're trying to decide if it has a horizontal or an oblique asymptote, you look at the degree of the numerator comparing to the degree of the denominator. And the rules are that if the degree of the numerator, p of x, is less than the degree of the denominator, q of x, then you're going to have a horizontal asymptote automatically at y equals 0. Example of that would be where you have a function, maybe you have x cubed over 3x to the fifth, something like that. The degree of the numerator is to the third power, the degree of the denominator is to the fifth power. So we have a horizontal asymptote at y equals 0 for that. Another instance where you would have a horizontal asymptote would be if the degrees of the numerator and denominator were equal, and then it would be the ratio of the leading coefficients. Example of that might be f of x. Maybe we have 4x to the third plus 5x squared minus 7 over x to the fifth, or I mean x to the third plus 5x minus 8. There, the degree of the numerator and the denominator are the same. So the leading coefficients are 4 and 1. So you would have a horizontal asymptote at y equals 4 over 1, y equals 4 for the horizontal asymptote there. Okay, so degree of the numerator less than the degree of the denominator, then it's y equals 0. If the degrees are the same, then it's the ratio of the leading coefficients. If it is another case, would be the oblique asymptote, is when the degree of the numerator is one more than the degree of the denominator. For example, you have a function that has 4x to the third power minus 10 over 2x squared plus 5, something of that effect. That would be one that has an oblique asymptote. You're going to do long division in order to find the equation of that oblique or slant asymptote. So oblique and horizontal asymptotes will never, ever occur together with rational functions. You will always either have horizontal and vertical asymptotes or oblique and vertical asymptotes. You will never have horizontal, oblique, and verticals together with those. So with rational functions, obliques and horizontal asymptotes never occur together. Let's look at some examples and see if we can determine what the asymptotes would be. So let's look at this problem. We have f of x is equal to x plus 1 over x squared minus 3x plus 5. So we look at the p of x, which is the polynomial on the top. It has a degree of 1. The polynomial on the bottom has a degree of 2. The top is less than the degree of the bottom. So our rule says that it'll have a horizontal asymptote. We'll abbreviate that HA at y equals 0. No calculation required. No math work. Just degree of the top is less than the degree of the bottom. It's automatically y equals 0 as a horizontal asymptote. Let's look at example 2. 3x squared plus 2x minus 7 over x squared minus or plus x plus 1. That's our rational function. We look at the degree of the numerator. The degree of the numerator is squared. It's 2. The degree of the denominator is x squared. So it's 2. The degrees are equal to one another. So the horizontal asymptote, HA, will be at the ratio of the leading coefficients, 3 over 1, which is y equals 3. And there is a horizontal asymptote. Notice that the degrees are the same, or the degrees have to be top smaller than bottom. Let's look at example 3 and look at the degrees of the numerator and the denominator. So we have A numerator that has a degree of 3, 4x to the third power plus 2x plus 1, has a degree 3. The denominator, x squared minus 5x plus 1, has a degree of 2. And the numerator is one more than the denominator. So that tells us that we have an oblique asymptote, abbreviate that OH. And the way to find that is to take long division of this polynomial. So x squared minus 5x plus 1 divided into 4x cubed plus 2. Excuse me, we need to put a 0, x squared, because it's missing that term, plus 2x plus 1. We'll do that long division in order to find the equation, which should be in the slope-intercept form of an equation to find that oblique asymptote. So we look at this and we say, okay, what times x squared gets me 4x to the third power? That would be 4x. 4x times x squared is 4x cubed. 4x times negative 5x be negative 20x squared. 4x times 1 is plus 4x. We're going to subtract that. These cubes cancel out. That's a positive 20x squared and a negative 2x. We bring down the plus 1. And then we say, okay, what times x squared gets me 20x squared be plus 20. So plus 20 up here. Distribute 20x squared minus 100x plus 20. Subtract that whole thing. Squares go away. And then we have negative 2 plus 100 to be positive 98x plus, minus 19. Now, this is your oblique asymptote. This is the remainder, which doesn't matter when we're trying to just find the oblique asymptote. Our oblique asymptote for this particular problem will be y equals 4x plus 20. Long division used to find oblique asymptotes. Again, remember, horizontal and oblique asymptotes do not occur together. They don't happen. That would be lab number 9 for Math 110.